Hello everyone. I've been receiving quite a few questions about what's the difference between an external force and an internal stress. And this is something that generally students do have difficulty with each year, and it doesn't have to be a complicated topic. It's just a little bit more difficult when I'm not in front of you with a chance to explain it. So I'm going to make this video here hoping to make your lives a little bit easier. So the first thing we need to understand is that the word external means outside. Okay, if there's an external force, it's happening on the outside of an object. If there's an external influence, it's an influence from the outside. Okay, somebody that doesn't belong to the community. Now, internal means inside. Okay, note the in. So an internal stress is something that happens on the inside of an object. And these are the ones that people think of generally. The internal stresses are like bending, compression, tension, torsion, all of those. Okay, so let's start on the external forces on the outside. We have two options. One is that you have a live load, and two is that you have a dead load. Okay, now these are the only two categories of external forces that we have. Remember, things that are alive generally move, they grow, stuff like that. So a live load is something that moves. Okay, as we're a dead load, when we think of things that are dead, generally, or non-living things, they're not moving. So these are non-moving. Okay, these forces happen first before an internal stress is created. Okay, so take for example, I have this box. Okay, now this is my fancy box. On this box, I am going to set a rock. Okay, our jagged rock is sitting on the box. Okay, now that rock is not going to move. It is what's considered a dead load. Okay, it's not moving, but it is putting a force on the box. It's pushing on the box. Okay, and that's creating an internal stress. So that rock is creating an internal stress of compression. Okay, the rock is trying to push the box downwards. Okay, now let's imagine that this is a large box. It was something that you got your refrigerator in. Okay, in the same regards, we're going to put your little sibling on the box. Okay, let's give them a nice big smile there because they are part of our science video. Now, this person is going to be moving left, they're going to be moving right. If you've ever had little siblings, you likely know that they don't stay still for very often. So because it's moving left and right, at the moment it's here, putting a compression force, then they're going to move over here, they're going to put a compression force, then they might come back over here and put a compression force. So we would consider them to be a live load. Now, it's very different how you plan for a live and a dead load. Okay? If it's a dead load, you know that it's going to be there 24/7. It's not going to change. If it's a live load, you know that it could be there and then it could leave for a bit and then it could come back. There could be multiple of them at once. Okay, so things like cars are considered a live load on a bridge. Pedestrians are a live load on a bridge. The pavement part of the bridge would be considered a dead load. Okay, the supports that are, if you think about the bridge that goes over the South Saskatchewan River, there's the supports into the river. They're holding up the pavement, and that would be the dead load. That pavement, if you go home and you come back the next day, that pavement is still there. Okay, but if you took a look at the cars on the bridge and you went home and you came back the next day, the cars that you saw are likely not going to be the same cars that are on the bridge anymore. So the cars are a live load. The person walking their dog, they're going to be long gone a day later. You're not going to see them anymore. So that person and their dog were a live load. Live loads, again, are things that move. Okay. Now, when we come over to the side of internal stresses, these happen because of a live or a dead load. So I want to stress that first. You have the live or the dead load first, the external force, and then that creates something inside of the inside of the object that you're looking at. So again, we have compression, and that is basically pushing down. Okay. Then we have torsion, and that is causing something to twist. Okay. We have tension. We can think of that as being like stretching or pulling of something. Okay, we have bending. That usually creates a U shape. Okay, so we have compression, torsion, tension, bending, and then we have shearing. And that's again when two things are moving side by side in an opposite direction. So if this block moves upwards while this one moves downwards, and they end up something like this, that would be a shearing force. Okay, and again, when we think back to those of you that have done the planet Earth unit, when you think back to tectonic plates, when the tectonic plates move side by side with each other, that is considered shearing. Okay, so again, please remember that the external force happens first, and then it creates this internal stress. Okay, so think about some of you that worry about things like a test. Okay, if there's no test, there's no worry. Okay, just like if there's no external force, there's no internal stress. Okay, so now all of a sudden Mr. Hamill strolls in and he says, hey, guess what? Big unit test tomorrow. That was the external part. Okay, that happened outside of you. That was something that happened to you. I came in and I told you about the test. Now, internally, what does that do to you? That causes you to start worrying, going, holy, I got this big test tomorrow, and he only gave us, 1 day's notice. So something external happened to create something internal. And the same thing is happening here. The external force happens, either a live load or a dead load, depending if it's something that moves or not. And then it creates an internal stress. Okay, and we have again these 5 internal stresses. So if you're still confused, by all means, ask questions. But I hope that this video is going to help you out.